Disclaimer: this content is created to assist students with their studies. It is not affiliated with or endorsed by Cambridge. Workbook and Learner's Book questions are used under the assumption of fair use for educational purposes. Welcome to Cambridge Answers. Today, we're exploring multiplication, multiples, and factors. We'll be solving puzzles, finding factors, and discovering some cool math tricks. Let's get started. Hey! Ready to dive into some number fun? Let's start with exercise 5.1. We've got 100 square. Just look at all those numbers staring back at us. From 1 all the way to 100. Now, here's the challenge. We're going to hunt for patterns. Shade all the numbers in the 2 times table with one color. Maybe a cool blue? Then pick another color and shade the numbers in the 5 times table. Let's go with orange. And finally, use a third color for the 7 times table. Green sounds fun. Now, pause and look closely. Do you see any numbers that are colored twice? Aha! Those special numbers belong to more than one group. For example, multiples of 10 are colored twice because they are multiples of 2 and multiples of 5. Sneaky little numbers, aren't they? Keep your eyes peeled. You're about to discover some cool number secrets.
Whoa there, something's missing. We've got a multiplication chart, but some of the numbers are missing. Can you figure them out? Let's look carefully. We already have some clues. In the first row, we can see 3, then a blank, and then 5. But wait, look below that. The numbers in this row are answers to multiplication problems. Like 2 times 3 equals 6, 2 times 4 equals 8, and 2 times 5 equals 10. So what number goes in that missing top box? That's right, it must be 4, because 2 times 4 equals 8. Now we're rolling. Look down this column. 4 times 5 equals 20, yes, and 6 times 3 equals 18. Got it. 6 times 4 equals 24. Boom! This chart is filling up fast. It's just like a puzzle. Each number helps us unlock the next one. Are you ready to solve more? All right, puzzle solvers, it's time to crack the code. Let's check out this colorful grid. It's bursting with clues. We've got 2 lists, across clues and down clues. Each one is a little math challenge. Let's start across. Clue 1, 6 times 8. That's 48. So we pop in a 4 and an 8 on the top row. Clue 2, 9 times 9. That one's 81. Type in a big, bold 8 and 1. Next, skip to clue 4. 24 divided by 6? Easy. That's 4. Pop it into the middle row. Clue 5. 63 divided by 7? That's 9. Drop that in too. Clue 8. 10 times 6. Ooh, big one. That's 60. So we add a 6 and a 0 to the bottom. And clue 9. 7 times 2? Yep, it's 14. Fill in 1 and 4. Boom! Across clues! Solved! Now, let's slide down. Clue 1. 6 times 7. That's 42. So we add a 2. Clue 3. 3 times 6. You got it! 18. In goes 8. Clue 6. 6 times 6? That square number is 36. Fill in a 3. And finally, clue 7. 8 times 3 is 24. We finish it off with a 2. Puzzle cracked! Math magic unlocked! Let's learn about factors. What's a factor? Let's find out. Imagine you have 12 cookies. Whoa, whoa, whoa. Not for you, Cookie Monster. These are for math. Go on now. Shoo! Okay, where were we? Yes. Factors. A factor is a number that fits perfectly into another number with no leftovers. So, if we share these 12 cookies, 2 times 6 equals 12. 2 groups, 6 in each. 3 times 4 equals 12. 3 groups, 4 in each. 1 times 12 equals 12. Even one big group. So, 1, 2, 3, 4, 6, and 12 are all factors of 12. They're like number buddies who work together to make 12. Easy, right? Alright, let's quickly move to the next slide. Uh-oh, is that Cookie Monster peeking again? Quick, let's go before he grabs the cookies. Phew, we made it before Cookie Monster popped back in. Let's move fast before he finds us again. First, let's look at 8. The factor pairs are already given here, but let's talk about them anyway. 1 times 8 equals 8. Easy. Then 2 times 4 equals 8. Nice and simple. So the factor pairs of 8 are 1 and 8, 2 and 4. All done, nothing missing here. Now let's solve for 18. Some are already written, but a few are missing. We start with 1 times 18. Already there. 2 times 9 equals 18. Yes, 9 goes right in. Then 3 times 6 equals 18. Perfect, that's our last pair. So the complete factor pairs of 18 are 1 and 18, 2 and 9, 3 and 6. And we're done. Wait, did you hear that? Okay, team, let's meet our first little bug. He's carrying the number 36. And hey, doesn't he look a little like a cookie? We'd better be quick before Cookie Monster notices. Let's go! We start with 1. Always 1. 36 divided by 1, that's 36. First pair, 1 and 36. Legs attached. Now 2. 36 divided by 2, that's 18. Nice. Another pair, 2 and 18. Next is 3. 36 divided by 3, that's 12. Perfect match. More legs for the bug. Try 4. 36 divided by 4, that's 9. Yes, that works too. Check 5. 36 divided by 5, that's 7.2. Nope, not a whole number. Skip it. Try 6. 36 divided by 6, that's 6. Whoa, the same number twice. When the numbers in the pair are the same, we only write it once. Right under the bug like a little tail. That's special. 7. 36 divided by 7, 5.1. Nope. 8. 36 divided by 8, 4.5. Nope again. And 9? We already used 4 and 9 before. That's our signal. We're just flipping the same pairs now. The factor pairs of 36 are 1 and 36, 2 and 18, 3 and 12, 4 and 9, and the special one, 6 and 6. Our bug is complete and ready to crawl off and do some math magic.
Nom nom nom. Bye-bye.
Yikes! Did you hear that? Oh no! Cookie Monster ate it! We'd better move fast. The next bug might be next on the menu. We just lost the first bug to Cookie Monster. We need to be quick with this one. Here comes our second little bug. He's carrying the number 45. And oh no, this one also looks like a cookie. We'd better hurry before Cookie Monster comes back. Let's go! Start with 1. 45 divided by 1, that's 45. First pair, 1 and 45. Legs attached. Next, 2. 45 divided by 2, 22.5. Nope, not a whole number. Try 3. 45 divided by 3, That's 15. Perfect. Add that pair. Next, 4. 45 divided by 4, 11.25. Nope, doesn't work. Try 5. 45 divided by 5, that's 9. Yes, more legs for the bug. 6. 45 divided by 6, 7.5. Nope. 7? Nope. 8? Nope again. And 9? We already used 5 and 9 before. That's our signal. We're just flipping the same pairs now. The factor pairs of 45 are 1 and 45, 3 and 15, 5 and 9. Our second bug is complete and ready to scuttle away.
Nom, 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 nom. Bye-bye.
Oh! Did you hear that? Oh no! Cookie Monster ate this one too! We'd better hurry to the next slide before he eats all the math bugs. All right, builders, hard hats on. We're building a math wall, one brick at a time. First, the red wall. We already have 5 and 3 at the bottom. What goes on top? 5 times 3 equals 15. Boom. A red brick. 15 locked in. Next, 3 times 2 equals 6. Another red brick done. 6. Now for the blue wall. 6 times 5 equals 30. Plunk. First blue brick up. And 5 times 7 equals 35. Thud. Second blue brick in place. Next, the green wall. 7 times 9 equals 63. This one's super heavy. Push, push, and done. And 9 times 4 equals 36. Another green brick finished. Now here's the tricky one, our yellow wall. Look closely. We have 6 and 42, but what's the missing number in the middle? The rule. The top brick is the product of the two numbers below. So 6 times what equals 42? Let's flip it around. 42 divided by 6 equals 7. There it is, 7. Place that yellow brick. Check the other side to be sure. 7 times 8 equals 56. Perfect. Yellow wall complete. And we're done. All our math bricks are stacked, the wall is solid, and you built it one brick at a time. Great job, builders. Okay, team, our hungry crocodiles are ready. Remember, they always chomp the bigger number. 3 times 8, 24. 5 times 5, 25. Chomp. The crocodile turns to 25 because 24 is less than 25. 6 times 4, 24. 4 times 6, 24. No chomp today. Both are the same, so we write equals. 7 times 8, 56. 6 times 9, 54. Chomp. Gulp. The crocodile eats 56. 54 is less than 56. 4 times 4, 16. 2 times 8, 16. No chomp here either. They're equal. And that's it. Crocodiles are full and happy. Okay, team, we need to find the numbers that do not belong to the 7 times table. But wait, who's that creeping in? Hey, it's Cookie Monster, and he's brought us the 7 times table to help. Thanks, buddy. Now, let's check the numbers one by one. 7. That's in the 7 times table, so we leave it. 17. Not in the 7 times table, circle it. 27. Not in the 7 times table, circle it. 37. Not in the 7 times table, circle it. 47. Not in the 7 times table, circle it. 57. Not in the 7 times table, circle it. 67. Not in the 7 times table, circle it. 77. That's in the 7 times table, so we leave it. 87. Not in the 7 times table, circle it. 97. Not in the 7 times table, circle it. Great job! All the numbers that aren't in the 7 times table are circled. Thanks, Cookie Monster! Now, shade any multiples of 7 on the grid. Let's see, 37, 38, 39, not in the 7 times table. 47, 48, not there either. But wait, 49 is in the 7 times table. Let's shade 49. Perfect! All done! Ready for a hexagon maze adventure? Let's start at the center where it says Start. Here's our challenge. Step 1. Move to any number that's a multiple of 2. Step 2. From there, hop over to a number that's a multiple of 5. Let's figure out all the possible paths. So first, look at the hexagons around Start. We see 2, 10, 14, and 18. All of these are multiples of 2. Let's try them out one by one. Path 1. Start to 2. Now, from 2, can we jump to a multiple of 5? Yep, there's a 5 right there. And even a 10. So our first 2 paths are Start to 5, Start to 10. Path 2. Start to 10. From 10, we can move to 5 or 25. Both are multiples of 5. So 2 more paths. Start 10, 5, Start 10, 25. Path 3. Let's try 14. From 14, look closely. There's a 15 just next to it. And 15 is a multiple of 5. So here's another. Start 14, 15. Path 4. How about 18? From 18, what do we see? There's a 20. Yep, that works. And wait, a 15 too. 2 more paths. Start 18, 20. Start 18, 15. All right, let's see what we found. That's 7 different ways to win the maze. Start to 5, Start to 10, Start 10, 5, Start 10, 25, Start 14, 15, Start 18, 20, Start 18, 15. So there you have it. 7 possible paths through our maze. Think you can spot them all without my help? Try it yourself. And if you find a sneaky path that I missed, drop it in the comments below. Let's see who's the real maze master. All right, time to find all the factors of 12. Remember, a factor is a number that divides evenly into 12. No remainders at all. Let's start from the smallest. 1, always a factor. Circle it. 2. 12 divided by 2 is 6. So yes, 2 is a factor. 3. 12 divided by 3 is 4. Perfect. 4. We just saw it. 3 times 4 makes 12, so 4 is definitely in. 6. 2 times 6 equals 12, so circle 6. And finally, 12 itself. Every number is a factor of itself. The rest? 8, 24, 36, 72? Nope, they don't divide evenly into 12. So our circled factors are 1, 2, 3, 4, 6, and 12. Nice and neat. Ready to become a multiplication detective? Let's go triangle by triangle and uncover all the missing numbers together. Let's check out our first triangle. Top circle, 5. Bottom left circle, 6. Bottom right circle, 4. Let's fill in the boxes. 5 times 6 is 30. 6 times 4 is 24, already given. 5 times 4 is 20. So the answers for this triangle are 30 and 20. Moving on to triangle number 2. Top circle, 5. Bottom left, 7. Bottom right, 9. Now, Let's multiply for each box. 5 times 7 is 35. 7 times 9 is 63. 9 times 5 is 45. So the boxes here are 35, 63, and 45. Triangle 3. All right, time for some detective work. Only 3 numbers are given this time. Left box, 28. Bottom left circle, 7. Bottom box, 21. Let's find the missing numbers. First up, the left box. What times 7 equals 28? That's right. 4 times 7 is 28. So our missing top circle is 4. Next, let's check the bottom. The bottom box says 21. We already have 7 on the left. 7 times what equals 21? 7 times 3 is 21. So the missing bottom right circle is 3. Let's just double check the last box. The top is 4. Bottom right is 3. 4 times 3 is 12. So the missing right box is 12. There you have it, the full triangle. For our last triangle, only 3 clues are given. Left square, 20. Left circle, 4. Right circle, 9. Let's solve. What times 4 is 20? 5 times 4 is 20. So the top circle must be 5. Now, let's fill in the other boxes. 5 times 9 is 45, right square. 4 times 9 is 36, bottom square. All done. And that's how you solve multiplication triangles. Just use the clues, think about what's missing, and fill in each number step by step. You're a real multiplication detective now. Now let's solve both multiplication grids step by step. First grid. Look at the numbers at the end of each row. We need to figure out what number times 2 gives us the answer at the end. The first row already starts with 5. That one's given. Next row. The last number is 12. What times 2 gives 12? That's 6. Next, the last number is 6. What times 2 gives 6? That's 3. After that, the last number is 16. What times 2 gives 16? That's 8. And the last row, the last number is 8. What times 2 gives 8? That's 4. Now, just fill in the rest by multiplying the row number by the column numbers at the top for each box. Second grid. Now let's use the clues inside the second grid to find the missing row numbers. First row. We see a 9 in the grid. When do we get 9 in multiplication? That's 3 times 3. Next row. There's a 25. When do we get 25? That's 5 times 5. Next row. There's a 49. When do we get 49? That's 7 times 7. Now we come to the fourth row and look. The number 6 is already given. And for the last row, there's a 100 in the grid. When do we get 100? That's 10 times 10. Once you have the row numbers, fill out the grid by multiplying each row number with the others, just like before. That's how you solve both grids. First, use the clues to find the missing row numbers, and then use multiplication to fill in the boxes. 14. Card puzzle. We need a total that is a multiple of 7. The cards are 2, 4, 3, 9. Try different combinations. 24 plus 39 equals 63, and 63 is a multiple of 7, so the answer is 24 plus 39 equals 63. Question 15. Now, cross out 2 numbers so that the sum of the remaining numbers in every row and column is a multiple of 5. The trick? Look for 2 numbers that are messing up the 5 times table pattern. If we cross out 4 and 6, everything left adds up to multiples of 5. Question 16. Syra is thinking of 2 numbers. Here's the clue. They are factors of 12, and the difference between them is 4. Let's list the factors of 12. 1, 2, 3, 4, 6, and 12. Now find 2 numbers that are 4 apart. 2 and 6, because 6 minus 2 equals 4, so Syra's numbers are 2 and 6. Want to watch the full solution for exercise 5.2 and get access to even more complete exercises and chapters? Just head over to patreon.com/CambridgeAnswers. The link is right in the description below.